All right, the last thing we're going to do in this section is talk about applications, okay? So for these ones, I'm having you do all of them, and I'm going to do two of the evens just to show you how it's done. Let's look at the first one. An oil slick is expanding as a circle. So, you spilled some oil and it is, expanding. The whole circle is expanding. And the radius of that circle is increasing at a rate of 20 meters every day. Express the area of the circle as a function of d, the number of days. So we need to find the area, right? That's what it says. Express the area. Let's find that area. Okay? Well, we need the area of a circle. Area of a circle is pi times the radius squared. But we're not done yet. That would be nice, right? Because what did the problem say? Express the area of the circle as a function of d, the number of days elapsed. So we have it in terms of a radius. It needs to be in terms of d. So we need to relate d with the radius, the number of days with the radius. Well, notice it's expanding at 20 meters every day. Right? So after day one, the radius is 20 meters. After day two, the radius is 20 more meters. Now it's 40 meters. After day three, it's 60 meters. So, this is our day right here, and this is our radius. There's a relationship between these two things. How do we write the radius in terms of the days? Well, notice these are all just multiples of 20, right? 1 times 20 is 20. 2 times 20 is 40. 3 times 20 is 60. So the radius is just 20 times the number of days that have elapsed. Well, if that's the case, and the radius is just 20 times the number of days, what were we asked to find again? I don't remember. I'm lying to you. I do remember. Express the area of the circle as a function of d. All right. So to get this in terms of d over here, if r is 20d, let's just plug that in. The area is pi times the radius squared, and the radius is 20d. So there it is. We can simplify this a little bit. Area is pi times squaring 20d, right? 20d squared is 20d times itself. So 20 times 20 is 400. D times d is d squared. Or a lot of times we'll write this with the number part first. 400 pi d squared is our area function. And again, a lot of times when we write functions, we write f of x. This is a of d. But I will accept it if you just write the a as well. You don't need the of d right here. Remember, this is not multiplication. This is function notation, just like f of x. Okay, and that's 66. We're also doing 68 together, just to give you a little hint on how to do these ones. 68 says we have a rectangle with a length of 10 inches and a width of 6 inches. I'm going to stop right there. We have a rectangle. I'm going to write that down. There's a length of 10 inches and a width of 6 inches. Okay, good. If the length is increased by x inches and the width increased by twice that amount, express the area as a function of x. There's two things I really want to unpack. This first thing, the length is increased by x inches, and the width is twice that amount. Let's deal with that first. So we have this rectangle, and the length we're increasing by x inches. So we're going to make a bigger rectangle. And that's going to be x inches more. And then the width we're also increasing, but we're not increasing the width by x, right? Increasing the length by x, it said, and the width by twice that amount. Well, what is twice this amount? that width is going to be extended by twice that amount. Again, there's still the 6 inches over here. I should have done it over there. Right, we're extending it over here by 2x. Now we have a much bigger rectangle. And what else did it ask? It asked us to express the area as a function of x. So in general, what is the area of a rectangle? It's length times width. We just have to find out what is our length. Our length used to be 10, but now it got extended, right? It's not just 10, it's 10 and that together. It's this whole thing. Well, that's just this piece plus that piece. The length is 10 plus x. I think we can write this as a of x, function of x. We have to multiply by the width. The width used to be just 6, but we are adding 2x to the width. So now it's those things added together. 6 plus 2x, like so. That's our area function. And again, I will accept this as well. If you just want to write a equal to 10 plus x times 6 plus 2x, that's fine too. If you wanted to simplify this, you could. I think it's kind of nice to have in factored form. Sometimes you want it simplified. You could FOIL this out if you wanted. If you wanted to write, this will be 60 plus 20x plus 6x plus 2x squared. This would be fine as well. And then write it in general form. So this x squared term in the front. And then 20x plus 6x is 26x. You could also write it like this, with or without the a of x. A lot of ways I'll accept for something like this. Okay, that's what we got for these ones. Let me know if you have questions on this application stuff though.